Alright guys, this is test 3.2 review. We'll start with the first part, transformations of cube and cube root functions. So let's go ahead and look at number 2. Number 2 says we have f of x equals the cube root of negative 2x plus 10 minus 4. Now with this problem, guys, I call this the Batman problems just because they're in disguise. You have to be careful. Anytime you have a horizontal stretch or compression along with a horizontal shift, you need to factor out the GCF. Or if there's not a GCF, you still need to factor out the leading number, the leading coefficient right here. So I'm going to factor out a negative 2. So you're left with x, and then negative 2 times what gives me positive 10. A negative times a negative is a positive, and then 5 times 2 is 10. And just be careful you have that minus 4 on the outside. And you can always double check, right? I can always go ahead and distribute back to make sure that I factored out correctly. Okay, so once I do that, now I can see this in nice transformation form. I'm going to list the transformations from left to right. So on the inside right here, everything underneath the radical, right, underneath for the cube root, is your horizontal shift. So right here, this first thing, this negative, is going to flip over the y-axis. And if you're flipping over the y-axis, that's a horizontal flip. Okay. Then the 2 right here, it's horizontal because it's underneath the radical. And you do the opposite, and I call it horizontal land. Anytime you're in horizontal, a stretch, compression, a shift left to the right, it's the opposite. So right here it looks like a stretch, right, because it's a number bigger than 1, but it's actually a compression, and it's by the reciprocal function, so by 1/2. Okay, and then here this looks like this is going to be your left or right. It looks like it goes left, but it's actually right 5. Right here we're outside, so if we're outside, that's vertical land, and everything is what it says. It's going to be down 4. And it says list the parent function. That just means which parent function is this. This is the cube root function. And so y equals the cube root of x. So you're just comparing this transformation, right guys, here to here. So that's number 2. Let's go ahead and go to number 3. So number 3, I have f of x equals negative 1/2 x plus 1 cubed minus 2. Now with this guy right here, this is the cube function. So we're comparing y equals x cubed. And right here with the parentheses, anything inside the parentheses, that is horizontal land, right, where you do the opposite. So start out here, you have a negative on the outside, you're going to flip over the x-axis. And if you flip over the x-axis, that is going to be a vertical flip. Then I have this 1/2, so that's vertical. And it's like you do exactly what it is. So it's a number less than 1, right? So it's a compression by what you see, 1/2. And here we're in horizontal, so you're going to do the opposite. So it looks like it goes right, but it's actually left 1. And then out here, it's vertical, so that's going to be down 2. Okay? Alright, now we're going to look at number 5. Now this one's a little bit tricky. So I kind of drew it already, pre-drew it. Let me cover this up. So number 5 right here, guys. This is the function that they give us. Now your parent function, right, if we think of this is the cube root. So let me go ahead and just kind of re-evaluate. So y equals the cube root of x, right? If I was to set up a table, always start with your origin, right? The cube root of 0 is 0. The cube root of 1 is 1, right? Because this means 1 times 1 times 1 is still 1. And then the next number that I can take the cube root of is 8. That's my nice pretty point. So the cube root of 8 is 2. And then I'm going to go backwards. So the cube root of negative 1 is also negative 1, because negative 1 times negative 1 gives me positive 1. And then positive 1 times negative 1 still gives me negative 1. And then the cube root of negative 8 is negative 2, because negative 2 times negative 2 is 4, and then 4 times negative 2 gives you negative 8. So those are my points right here. So I'm going to go ahead and do a little quick sketch. I have 0, 0, 1, 1, 2, 3, 4, 5, 6, 7, 8, 2. There's this right portion of my graph. Left 1, down 1, and then go left 8, 1, 2, 3, 4, 5, 6, 7, 8. Right here. So this is the cube root function, and if you can see here, we start at the origin, and then our next pretty point is you go right 1, up 1. So right here, if you notice, right, here's our parent function. You go right 1, up 1. But in this case that they give us, you're actually going right 1, up 2. That's going to tell me that you're going to have a vertical stretch, right, of 2 by a factor of 2 instead of 1. And how you can check, guys, is you can plug it into the general form. Y equals a cube root x minus h plus k. You can always check your math algebraically. And so your h and k, in this case, is your vertex. And right here, our vertex, you're going to shift right 2. So this would be 2, 0. And then your x and y is just any random point. It doesn't matter that's on the graph, but it's really good to pick a pretty point. So I'm going to pick this point right here. So what is that? 1, 2, 3, 2. So I have 4 points, right? I have 2, 0, 3, 2, h, k, x, y. Right here I have 5 unknowns. And so I'm just going to plug these points in to solve for a. And like I said, based on my graph, it should be 2. But I'm going to double check to prove it algebraically. So this is y is 2, a cube root, my x is 3, minus your h is 2, and then your k is 0. So right here I'm going to go ahead and simplify the cube root. 3 minus 2 is 1, so you get 2 equals a times the cube root of 1, plus 0, which goes away. The cube root of 1 is 1, because 1 times 1 times 1 is 1. And then we get a is 2. Ta-da! So there it is. Proved it algebraically, too, that our vertical stretch is 2. So I'm going to go ahead and write my equation. Y equals 2 times the cube root, and then we shift it to the right 2, so it'll be x minus 2. And that's it. That is our graph, because we don't go up or down at all.